If we remember from transformations that A was the vertical stretch, B was the horizontal stretch or shrink, C was the shifting left and right, and D was the vertical shift up and down. Well, in trig, it's sort of the same thing, but we have different names for it. A is considered to be A is called the amplitude. That's still a vertical stretch and shrink. It's still the same thing on there. The amplitude is though how high and how low it goes, but it does not have the negative in front, so it's always going to be the absolute value on there. So it's always going to be the absolute value of A. B is still going to be the horizontal stretch and shrink, but that's how we find the period. It gives us information about the period, and usually for a standard parent function, it's 2 pi. And then C is what we call the phase shift. That is still shifting it left and right like we did before. And then D is the vertical stretch and shrink. Not the vertical stretch and shrink, the vertical shift up and down. They're still the same thing as what we did first semester. It didn't change. But now we're just going to call them something different. So let's say I was graphing just a basic sine. So the sine on there, the amplitude or the vertical stretch and shrink is just going to be 1. The period for this is when it does one full cycle is going to be 2 pi. And the phase shift is, there is no phase shift because we're not moving it left or right. And the vertical shift up and down, there is none because we're not moving it up and down. So when you do this, you are going to be able to take the period and break it up into 4 equal parts. So you're going to take this and you're going to break it up into 1, 2, 3, 4, which we know are the quadrantal angles. So it's pi over 2, 2 pi over 2, which is just pi, 3 pi over 2, and 4 pi over 2, which is just 2 pi. And you do the same thing to the other side. And we're going up as high as 1 and as low as -1, and it's sine, so we're going to go here, 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 and that's the graph of sine. That was really squiggly there. So again, you take the period, split it up into 4 equal parts, which are the quadrantal angles. The amplitude is how high and how low you go. And then we're not shifting to the left, we're not shifting it right, we're not shifting it up or shifting it down. And that's how we have the amplitude of sine. Now, let's say that we are going to change this, and it's pretty much going to be exactly the same thing, but now what we're going to do is we're going to graph this one. Now the amplitude is different. The amplitude there, this is your A right there, is going to be 2/3. It's always the absolute value, and so since this is already positive, we're going to have that. So remember, amplitude is the absolute value of A. And then the period, it's going to be 2 pi. For a parent function, since it's sine, it's 2 pi, and you're going to take the b and you're going to divide it into 4 equal parts because that's the horizontal stretch and shrink. Remember, it's 4, so we're going to shrink everything because it's the reciprocal. So in this case here, we're going to take 2 pi, the original parent function, period, and we're going to shrink it. So we're going to shrink it. We're going to take the 2 pi and we're going to shrink it by 1/4 or multiply it by 1/4. And so that's going to be 2 pi divided by 4, which is just going to be pi over 2. That means that the new period is no longer 2 pi. Now we've shrunken the horizontal x values or angles to 2. So everything's going to happen between 0 and pi over 2. There is no phase shift because there's no C and there's no D, so therefore there is no vertical shift up and down. We're still going to separate because we're shrinking it. What we're shrinking are the quadrantal angles, but now they're no longer going to be the quadrantal angles. We want to divide the pi over 2 into 4 equal parts. So I'm going to take the pi over 2 and multiply it by 1/4 because that's dividing it by 1/4. And so then what we get here is going to be pi over 8. So the first one is going to be pi over 8. The next one is going to be 2 pi over 8 because we do the counting of the quadrantal angles. So that's going to be pi over 4. And then the next one's going to be 3 pi over 8. So that's 3 pi over 8. And then the last one is going to be 4 pi over 8, which is just pi over 2. So that means it's going to do one full cycle within pi over 2. And then the other side is still the same thing. It's just going to be negative pi over 8, dot, dot, dot. And then how high does it go? It goes as high as 2/3. So I'm going to write down 2/3 there, and then 2/3 right there. And so since this here is the sine graph, we know that the sine of 0 is still going to follow the same things as the parent function. At 0, it's going to be 0. At pi over 8 is going to be 1, because the pi over 8 corresponds to pi over 2, and the pi over 4 corresponds to pi. We just shrank everything so it fits between 0 and pi over 2. It's going to be one full cycle. So then here and then there. So it's going to look like this. And then on the other side, it's going to be the same thing. And so now it's going to look like that. And so that's what the sine on there. So instead of going from 0 to 2 pi, we went from 0 to pi over 2. These are still the quadrantal angles because everything got shrunk. All right, so cosine. Cosine is no different. It's still the same thing. On this one here, if I look at it, it has the -2 there. That is your A. So we want the absolute value of A on there. So that one there is going to be 2, not -2. And then the period, we're going to take this pi. That's how much is either stretching or shrinking. In this case, because it's greater than 1, we're going to be stretching it. So we're going to take the parent function. Cosine's parent function is going to do one cycle in 2 pi. So we're going to take the 2 pi, and then we're going to shrink it by 1 over pi. And so then that's going to cancel there. And so we're going to end up with 2. So that means that we are going to divide everything into, we're going to divide 2 into 4 equal parts. So that means that this is going to be 1/2, 1, 3/2, and I'm sorry, yeah, 3/2 and then 2. So it's 1, 2, 3, 4 pi over 2, right? So it's going to be 1/2, because we're going to divide this into 4 equal parts. And so I have 2 over 4, which ends up being 1/2, and then 2/2, and then 3/2, and then 4/2. And that's what we get there. And then we have the same thing on the other side. And so the we are going to, the period means that it's going to do one full cycle within 0 to 2. There is no phase shift. There is no vertical shift. So how high are we going? We're going as high as 2 and as low as -2. And so this is cosine. So it's going to start there, there, and then there, there, there. It makes it so much easier if you know what the parent functions look like, so that you don't struggle through it. And there you go. Okay, and then this one over here, for cosine of x plus pi, the amplitude is 4. It's positive on there. There is no b, so the period is going to be 2 pi. So we're just going to separate that into 2 pi. So it's going to be 2 pi. So it's going to be pi over 2. It's just the basic quadrantal angles. 3 pi over 2. We got that. And then the phase shift there, this is your C, so that means that everything's going to be shifted -pi over. And then V is the vertical shift, that means up and down, that's nothing, so we're going to have 0 there. Okay, so then this one here is cosine. So cosine is going to go as high as 4, as low as -4. So what I like to do is I like to do the dotted line. So I want to include these two and this one. Since this one is 0, we don't have to worry about it. But I like to include this one, so it's going to be dot, dot. We're going to do the dotted line. And this one here is going to be the dotted line. Okay, so this is not the actual curve on there. I just do it in dotted lines. The actual curve is going to be when I shift it a negative pi. So this one here is going to go -pi. So that means pi is 2 tick marks. So I'm going to move this 2 tick marks. So this one went in this direction, 2 tick marks. This one went in that direction, 2 tick marks. This part went into that direction, 2 tick marks. So once you start getting a hang of it, you know where the rest of it is going to be. And so then you have this, and then you have that. So it's going to look like this. And so that has been shifted. Everything has been shifted over pi. So that's everything has been shifted to the left by pi. Okay, and then one more. This one has everything in it. So this one has the amplitude of 2/3. This one here has the sine, and notice how this one has a phase shift and a 2. Remember from the first semester, anytime there's a b, you always have to factor it out. So this is going to be the sine of 2x divided by 2. And then this here is your D because you're adding to it. That is your A. This is your B. And this here is your C. So the period is going to be taken by the 2. So it's a sine curve. So we're going to do 2 pi divided by 2. And so then that one is just going to be pi. So we're taking the 2 pi, this is going to shrink it. And so we are going to say that this one here is going to be pi is the period. The phase shift, that means that you're moving it left and right. That's going to be the positive. We do the opposite and it's shifting up by 1/3. So how do we split this up? So we know we want it into 4 equal parts for the quadrantal angle. And so the quadrantal angle is pi. We're going to divide it into 4 equal parts. So the first one's going to be pi over 4. The next one is going to be 2 pi over 4, which is going to be pi over 2. And then the next one's going to be 3 pi over 4. So that's 3 pi over 4. And then the last one is 4 pi over 4, which is going to be just pi, which is what our period is there. And it's the same on the other side. It's going to go as high as 2/3. So this one here is going to be 2/3. The only thing is that this is a vertical shift of 1/3. So that means that everything's going to shift up to 1/3. So this one here is going to go up as high as so 2/3 plus 1/3, that is going to be 3/3. So everything from 2/3 is going to go up. And then when I have negative 2/3, shifting up 1/3, we know that that's going to be, so I'm going to erase this. So that's going to go up as high as 1. And then the negative 2/3 here, it's going to give it to be negative 1/3. And so that's going to go up as high as negative 1/3 on there. And so everything's been shifting up 1/3 on there. Okay, so we're going to then sketch this because it's going to be between those. It's sine, so we're going to start, it's not negative, so we start here, then we go up, then down, then right there, then right there. Yeah, very good. And then right here, right here, right here, and then back to there. So this one here is what our graph looks like. But what I want is a phase shift. So we need this phase shift. So we got this, and we got that, but we need to shift it all over. So everything's going to go up. Pi over 2 is 2 tick marks, and we're going in the positive direction. So that means that this one here is going to go over 2 tick marks. This one here is going to go over 2 tick marks. And so this one here is going to go over 2 tick marks. So you already know the pattern there. So we know it's going to go there, and then back up here, and then up here, and then down here, and then down there, and then up. So this one here, it's what it's looking like. And that's how we graph the sine and cosine. Now, if we wanted to change this, so if this one was one, let's say that I had this, but instead it was the cosecant of 2x minus pi, I do the same thing that I just did. So if it was cosecant, I do the same thing that I just did. Wherever there's an x-intercept, I want to put down this. The cosine and the secant, the cosecant, these are the asymptotes, and then you just flip them. So if you were given this problem instead of the top problem up here, all you would do is graph the sine, the same thing you did there, and then you just flip them out. Okay, very good.